Why do greater than absolute value inequalities lead to two separate solutions? Imagine you are standing in front of a number line, trying to find all the points that are more than a certain distance away from zero. It might seem simple, but it actually splits into two different groups. When you see an inequality like absolute value of x is greater than a number, it means you are looking for all numbers that are farther than that number from zero, in either direction. The absolute value of a number measures its distance from zero, no matter if the number is positive or negative. So, if the absolute value of x is greater than 3, it means is more than 3 units away from zero. On the number line, this includes all numbers less than -3 and all numbers greater than 3. These two groups are separate because they are on opposite sides of zero. This is why the solution involves two different inequalities. For the case where the absolute value of x is greater than a positive number, you split the problem into two parts. One where the expression inside the absolute value is greater than the number, and another where it is less than the negative of that number. For example, if you have the inequality absolute value of 2x plus 5 is greater than 11, you write two inequalities. 2x plus 5 is greater than 11, and 2x plus 5 is less than -11. Solving each inequality separately gives you the solutions. For 2x plus 5 greater than 11, you subtract 5 from both sides and then divide by 2, which gives greater than 3. For 2x plus 5 less than -11, you subtract 5 from both sides and divide by 2, resulting in x less than -8. So, the solutions are all numbers less than -8 or greater than 3. This is different from inequalities where the absolute value is less than a number. Those solutions form a single, connected interval between the negative and positive values. But when the absolute value is greater than a number, the solutions are outside that interval, which naturally splits into two parts. Think of it like this. The absolute value measures how far a number is from zero. When the distance has to be more than a certain amount, it means the number has to be far away in either direction. That's why the solutions are to separate groups or intervals on the number line. Understanding this concept helps you solve many real-world problems. For example, if a machine part must be more than a certain distance from a target measurement, you can set up an absolute value inequality and find all acceptable measurements. In summary, greater than absolute value inequalities lead to two separate solutions because the absolute value measures distance in both directions from zero. When the distance must be more than a specific value, the solutions include all numbers far enough in both the positive and negative directions, creating two distinct intervals. This idea is a key part of algebra that makes solving these inequalities clear and logical.